I love demon cats. These are cats summoned forth from the underworld to destroy those who would do us wrong. But best of all, these demon cats can be summoned for the low, low price of free. There's just one catch. When you summon your cat, there's no guarantee you'll get the demon cat everyone wants. An all black cat with large canines and aggressive temper. There's a chance that instead you'll get a sweet and gentle tabby demon cat with small canines who mostly knocks things off your desk. So, what are your chances of getting an amazing demon cat? What we know about demon cats is that they have three linked loci that we can categorize as coat color, canine size, and temperament. Demon cat traits can be dominant or recessive. Tabby coat, large canines, and aggressive temperament are all dominant traits, while black coat, small canines, and gentle temperament are recessive. The law of segregation ensures that demon cats will produce gametes that contain one allele from the two possible alleles that make up a gene. The law of independent assortment states that these alleles can segregate independently from one another during meiosis. Linked traits violate the law of independent assortment. Generally, alleles on the same chromosome will travel with one another during segregation. There are exceptions, however. Depending on the distance between one allele on a chromosome and another on that same chromosome, there is a chance that recombination will occur during prophase 1 of meiosis. Luckily for us, Underworld Direct, humane and accredited providers of demon cats, unlike those truly evil guys at Amazon, have provided us with a genetic map of the F1 individual based on their most recent litter of 1,000 cats. The map represents the two chromosomes where each set of alleles reside. This also gives us a hint as to who the parents were for the heterozygous cat. Underworld assures us that the F1 cat comes from pure breeding cats. Therefore, for F1 to occur, both parents would have had to been homozygous for tabby coat, large canine, gentle temperament, and black coat, small canine, aggressive temperament. In this map, we see that the distance of region 1 is 23.5 centimorgans and 18.2 centimorgans for region 2. The closer an allele is to another, the less likely a crossover event will occur. CMs can help us determine the probability of a crossover event occurring and even a specific gamete resulting from a crossover event. For example, if we wanted to determine the probability of a DCO or double crossover event occurring, then we would multiply region 1, region 2, and C, the coefficient of coincidence. The result is that we would expect to see a DCO event occur 0.039 or 3.9% of the time. This also means that if we multiply by half, then we'll see that the gamete produced from the event has a probability of 1.95%. This is very sad since the most desirable cat will be the rarest to obtain. A single crossover event occurring in region 1 has a probability of 19.6% calculated by subtracting 0.235 from the DCO event 0.039. Calculating single crossover 2 only and no crossover event as well will allow us to determine the probability of producing all 8 gamete types. These 8 gamete types come from the different combination of crossover events that can occur at none, one, or both regions. Our coefficient of coincidence indicates how close the number of events occurring were to the expected number of events. The closer to 1, the more confident we can be in our probabilities.